Hello, my name is Claudio Lázaro Espinel and my code is 40172953 and my article number is 7 and it's called Properties of Mortar with Waste Clay Bricks as Fine Aggregate. This work belongs to the Faculty of Civil Engineering of Zhengzhou University of China. The principal objective of the article arises from the need to solve the problem of recycling construction waste as soon as possible and develop new ecological building materials. From this article, it should be noted that Na is a natural aggregate. RCBA is recycled crushed bricks aggregate. The second part is the experimental one. Original Portland cement was used in this part. Also, the RCBA products method, which is obtained in the demolition of buildings, was explained, and the next step is crushing the material, and the next step is sieving of particles with a 5 mm sieve. The image represents the type of production stage. For A, it's a demolition. For B, it's a RCBA. They are particles greater than 5 mm, and B are particles of 0 in 5 millimeters. The table 3 show us the physical properties of the fine aggregates obtained. There we can see the evident density, apparent density, compact density, among others. River sand and Portland cement were also used, and the table 1 shows the chemical composition of cement, and the table 2 shows the properties of ordinary Portland cement. The experimental base of the article starts from 3 directions that were experimented with the aggregate, which are SA, RA, and RW. SA contains a particle size of 0.15 to 5 millimeters, and the additional toilet was 100% saturated surface dry state. RA contains a particle size to 0 to 5 millimeters, and the additional toilet was 100% saturated surface dry state. RW contains a particle size of 0 to 5 millimeters, and the additional toilet was 75% saturated surface dry state. RCBA was used as natural sand replacement to 25%, 50%, and 75% B weight, which was named as 25 and 50 and 75 respectively. In the results and discussion, the properties of RCBA are analyzed. The graph 3.1 shows us the granulometric curve representing the behavior of Na, RCBA, fine upper limit, and fine lower limit. The natural fine aggregate generate only 4% particles smaller than 0.15 millimeters, while the RCBA obtained 22% 8% in the same size range, which means the RCBA produced 5 times more particles under 0.50 millimeters than of Na. The next parameter to evaluate was fluency, the increase of the replacement ratio of the RCBA. A trend of increased first and then decreased has been observed. Another factor to analyze was the compression stress. Here, the additional toilet content and particle size of the RCBA have significant influence of the strength of mortar. Additionally, the replacement ratio of the RCBA has little influence on the strength of mortar. The RCBA with the partially additional water content and 0 to 5 mm particle size distribution is optimal to the strength of recycled mortar. Deflection stress was also calculated, with which it can be included that the RCBA is detrimental for the initial deflection and can also be beneficial for the late deflection. The fifth value that was analyzed was the composition of the RCBA microstructure, where the chemical composition is shown and shows that the main components are silicon oxide, aluminum oxide, and iron oxide. The X-ray diffraction test shows that it is composed mainly of quartz, calcite, albite, and anorite. For the morphology of the microstructure, this analysis, a natural aggregate was compared with the RCBA, and it was obtained that first, for the natural aggregate, the texture is smooth and spherical. Also, that its microstructure is dense. For RCBA, the texture is broad. It's not dense, and because the surface texture is irregular and the edges and angles are greater, this causes the friction between particles to increase, which produces a decrease in the fluidity of the mortar. Finally, in the discussion, the RCBA can pay the puzzolanic activity in the cement mortar, and the strength of mortar is controlled by the effective water-cement ratio, while the additional water content of the RCBA changes the effective water-cement ratio of mortar. And the RCBA has higher water absorption, and it will absorb moisture in the cement slowly at the early stage.